Thank you. Thank you for the introduction. I did not understand a word, so hopefully you were honest. Probably one or two of you have seen my very short presentation in the morning, and by now you should know that I always bring chocolate. I usually bring one of my books I write, but I only write German books, so I thought it was of no use if I brought a German book, so I brought chocolate again. This time, I show you a very simple, obviously simple problem. You know this continent on the south of the Earth, Antarctica? It's a fairly large continent, and my question is, how many time zones are there in Antarctica? And from a purely logical reason, there could be only one single correct answer. 24? 1? 12. 12 earns you a bar of chocolate. It's not correct, actually. It's 11, but that's completely illogical. So there is no reason, whatever, why it should be 11. It should be 24. That's the only logical reason, or the only logical argument, make it 24. But it's 11, I don't know why, but this is fairly typical situation where we have to deal with in real life. So many things are not logical, so they should be different from what they are actually, and that holds for the topic I want to talk about, that is legacy systems. So existing software systems are usually not built as they should be built. They have been grown from some hello world problem up to some huge beast. And I will talk about such a beast. I am not allowed to talk about my real clients I worked for. I have non-disclosure agreements, so I'm not allowed to mention their names. So I compiled the story you hear from various sources without disclosing anybody in person, but everything except 3 slides is real, so it has really happened. And I'm going to tell you when those 3 slides come up. So it's 3 lies and the rest is true. So I have about 60 slides, and the most disastrous things in that legacy system are true. And I'm talking about a fictitious company called SAM. SAM stands short for Sell and Make Money. That's true. That's what the company wants to do. They are selling products, and they want to make money. And you don't need to read all those lines here. It's an e-commerce company where you can order the products online. And to make it a bit more transparent what that means, I brought you a little bit of company history. The company was originally started as Gray Inc., was founded in the US, came to Germany, to Berlin in 90-something, so long time ago. And the company owners wanted to grow, and you can do 2 things when you want to grow your company. You can hire more people, but that is a slow process, or you can acquire other companies. You can just buy other companies. That's what they did. They bought other companies to broaden their e-commerce portfolio. So all these boxes you see here are different companies that had been bought by our original Gray Inc. Gray Inc. was transformed to Red Inc., went public, and now it's called SAM. So this is the company history. You'll see a similar image again when we talk about the structure of the application we are talking about. Now, the system I'm going to show you is called Venom. Venom is an English term for snake poison. You know the term? So it's really dangerous. Venom is also a 2019 horror movie. I don't mean the movie, but it's still a horror story I'm talking about. Now, the rise of the system, this Venom system addresses private persons that, for example, want to buy some products like a cupboard or tables or wardrobes or anything else, but they want to customize those in dimensions, in material, in color, and so on. So we have this configuration programs where you can configure this cupboard in the exact dimensions you want, with a special door, with a glass door on the left and a wooden door on the right, whatever you want. You can customize that. We have another kind of users from federal administrations. So I have this guy here. He is heading the administration of an embassy overseas. Oh, embassy business is difficult because in embassies you have some secrecy requirements. You don't want the Brazilian workers to work in the German embassy. So if you, for example, redesign your garden in your embassy, you want the workers from your country to work in the embassy. You want material from your country in the embassy, and this Venom system knows how to organize all that. That's a pretty tricky thing because you need to transport goods from one country to all over the world. It's a bit of difficult logistics, customs, legal issues, and so on and so on. And another user group is non-profit organizations. From medicine, from pharmacy, catastrophic aid all over the world. And these guys have completely different requirements than these embassies or these private customers. These non-profit organizations usually, for example, there was an earthquake in southern Sudan, and they phone or they configure, they need 200 tents to be delivered to Sudan. They don't care about the color, but the tents have to be in Sudan in this catastrophe area in the shortest possible time. So again, this is a very different business use case, different requirements, and this Venom system can handle that. These were just a few examples to show you the broad spectrum of use cases the system is supporting. And one added value that system provides, you buy these things and everything is included. Like interactive configuration, you have planning, you have training for complex machinery, everything you need, it's all included. Now, such a system that has been developed since the 90s probably becomes legacy. And that's exactly what happened to our Venom system. And you have seen a similar picture in the company history, and now you see the history of the Venom system. Originally, it was written in COBOL. Anybody of you had programmed in COBOL? It's no fun. Was it fun? He shakes his head. No fun. They introduced some Java to the system. It became some more Java in a catalog system over here. They bought another mainframe-based system, but this one is based on AS400 and it's not IBM ZOS. They integrated some Python stuff, so it became a mess of different languages and different histories, all integrated into one Venom system. Has anybody of you ever integrated systems? Okay. Integration can be done in two ways, exactly two ways. Good or fast. Yeah, but in really this is not funny, because usually some management guy comes up to the development room and tells us, oh, you have to integrate that, and it has to be finished by next week. Sir, what do you mean by integrate? Don't care about the details. Make it run next week. So, usually I call those integration disasters, not integration projects. They have a fixed date next week. They have a severely limited budget. They have no defined requirements. Make it work together. That's no clear requirement. And the management just pursues their own goals. So instead of doing a good job, you see here the two, let's call those domain models of the two systems to be integrated. Our Atlas software is doing customs. So when you import some goods into another country, you have to pay some customs for it, and this is software that can handle that. It's all centered around customs. Now you have another subsystem, our original sales system, that's centered around products. It's very similar, so you could come up with a combined model. That would be the engineering approach. So think before you program, come up with a combined domain model, and migrate both systems to the new domain model. That would take a little longer than next Friday. So what we do instead, we implement mapping components. So some glue component from the custom system that enables this Atlas system to access the SAM data. We need some mapping code in the SAM system too. So from COBOL, we now can access our relational model. It's just wrapping code. So we built a layer on top of the original systems. And my thesis is that all those boxes in red are in really technical debt. So it's a waste. You shouldn't have that. But we have those waste, those technical debt, on about 25 parts of our system. So this waste is spread all over the code, makes it way more difficult to understand, is dangerous for performance, and so on and so on. So it's really bad to work that way. But the guys who did integration, you really know there is no way out of that instead of thinking and making it slower. But slow is no option often. So this is a matter of fact, very bad thing we have. Now, I introduce another person. I call him Donald for no particular reason. He is member of the board of directors. He is the CTO, the Chief Technology Officer. He is no programmer. He cannot develop software. He is a management guy. He's wearing a tie. This is no bad thing, wearing ties, but wearing ties as technical manager is probably not the best you could do. And he was responsible for all these mergers and acquisitions. So he was one of the guys entering the development room, telling people to be ready next Friday. So he wants to bring that Venom system out of the bad situation, wants to transform it into something better. And what he does, he interviews a few guys. He notices you have a decline in revenue, the time to market is really bad. He notices that we currently don't have mobile applications. Oh, typical internet now is mobile. More than 60% of all internet traffic is mobile traffic. And our Venom, our e-commerce system, doesn't support mobile in 2019. No good. So, he concludes developers are bad. Code is bad. His conclusion from his conclusions, improvement is not possible with the existing system, so we have to write a new one. Ever heard of that? This Donald had been part of many strategy consultant conferences. He went, do you know Gartner Group, one of the top strategy consulting IT companies, most expensive consultants on the planet? They proposed an approach they called bimodal IT, meaning, in short, leave your existing systems, these big ships, running as they are, and build new systems, very small ones, very agile systems. In short, found a startup next to your existing company. That's what this Donald tries to do. So his proposal, we found a new company. Instead of repairing the old system, we found a new company where Donald is becoming CEO. And the idea is we call that company Busy. At least that sounds positive. Better than snake poison. So he founds the company Busy, and the idea is to use the old system, take over a few persons from the existing company, and hire new people in development and architecture, and after a few months we have a new system, and we replace the old one in a Big Bang approach. That's his basic idea. Now, the original company SAM is located in Berlin. In a very, I've worked in that part of Berlin. It's a very beautiful part of the city. It's very simple to go to. There is metro available. But as Berlin calls itself the startup capital of Europe, it's both very difficult to find proper office space. So office space in the center in Berlin is really difficult to find. So this Donald rents something a few dozen kilometers off the center, which is difficult to reach. And as a motivated developer, you want to be in the center and not in the outskirts, in the countryside, which isn't even beautiful in Berlin. So 2 months later, they have this office, but things are not going that well. 3 months later, the famous 100 days in the office, we have very promising prototypes. What's a prototype? Something a developer invents without any restrictions, without any real business needs. It's just showing a nice UI. They are very delayed in getting new people on board. They had planned, after 3 months, to have 16 developers on board, but they found only 6. Only 6 persons were willing to go to the countryside to work. So as a workaround, they hire some external consultants, which are way more expensive, so they spend more money, which is not good, but that's the resume of the first 100 days. After a half a year, in the original Venom system, sales are still declining. And the customers of the existing system become more and more unhappy because some core developers from Venom have been moved over to Busy, to the new company, so they cannot develop features in the original system, and the new system isn't live, it's not productive. They have to clarify requirements, which is going really slow because of that mix of 2 companies, and in the new company, in that new startup company, the first people quit. In a startup city, you have these startup meetups every week. So if you join one of those meetups and tell the others, oh, in my company Busy, things are not working out well, somebody will come up, hey, move jobs, come to us. And yeah, that's what happened. I experienced that myself firsthand in a newly founded startup in such a situation, and your new developers just will go away. So, very difficult situation for the new company. After 12 months, after a year, remember they are working on prototypes. Their prototypes are looking rather good. Management decides, oh, it's good enough. We are finished. We go live. That's a management decision. It's not a technical decision. Developers say, oh, we are not finished. Especially our data migration hasn't finished. We need the historical data to give the clients the appropriate rebates and rates for the products. It's declared finished. Anybody experienced a declared finished in system development? You are still smiling and you still have a head, so it can't have been that bad. Now, they go live and disaster strikes. They have no experienced operators. They have never operated a productive system before. Operation is difficult. DevOps is not just little operations on top of development. No, operating systems is difficult. That's probably a reason why you are here. It's not a trivial, we just move a switch and then everything goes right. No, it doesn't go right. So you need some experience in operating productive systems internationally, various countries, and so on and so on. So disaster strikes. The administration of the new company is massively overwhelmed. They don't know what to do. So management decides to roll back. Oh, that's even more of a disaster. That's the time when the supervisory board, the top-level management board of the whole company decides, oh, we have to do something. Maybe that approach founding a startup was not perfect. You know what happens in such cases? The top manager decided we need a startup and completely failed. What happens to the top manager? In Germany, he becomes minister. I don't know what's happening in other worlds, in other countries, but Minister of Technology. And there is a press release where the company praised the good cooperation, successful implementation of mission-critical. What's a successful implementation? It depends on the point of view. For that Donald, it was a success. He now knows how to not found a startup. That's an experience, and it's a success for him. I can name a few German ministers with such a background. Not in IT, but this is really strange. Now, let's give it another try. There is another guy called Aaron. Aaron has a development background. He had founded his own company, grew his own company, sold it. He's not rich, but he has some technical experience. Aaron decides to do it a bit more systematic and not just rely on mouth-to-mouth words, but to give it a more detailed look. He applies a method called AIM, Architecture Improvement Method. That's an open source project. I participate in that project, so it's adverts, but it's open source, so please let me market open source approaches. Architecture Improvement Method proposes to identify problems first before you start programming, to prioritize these problems, and then to start improving. Now, what we do, we analyze various aspects of such a system. The first thing, we talk to some stakeholders. What's a stakeholder? Is any person involved in the system. They know about a lot of problems and their solutions. I show you an example. I name her Kathy. Her original name was different. She complains about dependencies. She complains about build and deploy horror. So DevOps not done right so far. She complains increasing work hours, lack of overview, lack of innovation, and so on. Quite typical. We interview a second person, a UI developer. He complains that small changes take longer and longer. So due to lots of dependencies and intransparencies and so on, he complains about technical debt. That's a problem for guys like you. If you have these, you remember the red boxes, this technical debt stuff, it's very difficult to do small changes because of these. Now, stakeholders know a lot of problems. And my personal mental model of a problem is I write it on a red or here orange note card. I attach these note cards to a space in a project room so we get an overview of our currently available problems we currently suffer from. Now, let's look a bit into the architecture of the system, into the code structure. Oh, this is the code structure of our Venom system. All the boxes represent certain components in the architecture. All the lines are some dependencies. And it's very colorful, and all the colors represent a technology, a programming language. Welcome to the world of polyglot programming. Or should I say, welcome to the disastrous world of polyglot programming. There are parts of the system where we have a mix of Python, PHP, and COBOL. You programmed COBOL before, you don't want to mix those up. You don't want COBOL in your system, but this is it has been grown that way due to this integration disasters. Now, it's really difficult to analyze such a system because if you apply conventional metrics or analysis tools, they are often restricted to certain languages or language families, so that makes it a bit hard. I want you to introduce to a guy that really exists. The others are persona I brought you, but this John Austerhout really exists. He's a professor of computer science, and he is a programmer. This is a good combination. A professor of computer science who is a programmer by himself is very good. I would have liked to have one of those guys myself. You know TickleTK? It's a language and platform. He has implemented TickleTK since the beginning. So he's the father of Tickle. Raft is a consensus algorithm in distributed systems. He invented the algorithm, he implemented it, and he proved it correct. I tried to understand the proof. I didn't understand. But he has written himself millions of lines of source code. So if John tells you something about programming, you better listen. In his very nice book, The Philosophy of Software Design, which is a very practical book, it's not philosophical, it's very practical, he has introduced a term, the tactical tornado. A tactical tornado is a person that does quick hacks instead of thinking a little in advance. So, solving problems the tactical tornado way is a way into disaster. And in our Venom system, we have quite complicated pricing calculations. Because our products are so complicated, pricing them is difficult. And we have a component called pricing engine. And everybody in his or her right mind would expect pricing rules to be implemented here. In our Venom system, guys implemented the pricing rules within the middleware. Middleware is responsible for the transport of an XML or JSON message to another component. Nothing else. But our middleware calculates prices. That's a completely strange way of working. I call this opportunistic programming. Why does the middleware calculate prices? Because we had a requirement for a price change. The pricing team was overworked. We don't have time to do it, so the middleware team can do it instead. The middleware team has no idea of how the pricing engine really works, so they do it in their technology, and then you find pricing rules in the middleware. It's completely strange. I experienced that myself. So if you try to debug a badly calculated price, and it's simply not available in the source code because it's in the middleware. Really a disaster. This is very bad. So we have a lot of architectural issues in our building blocks here. This is the second slide that's wrong. The minister's slide was wrong. So my person I mentioned before, this Donald, wasn't elected minister. That was wrong. This is wrong too. I invented some Flash. Anybody using Flash? Adobe ActionScript Flash? Who of you has a mobile phone where Flash is still working? That's what I expected. Nobody. But our configurators in the SAM system only work on Flash. That's why you can access the website on Flash, but you cannot buy a product. Very bad. Now, Flash is bad. We could analyze. We are looking for problems, still looking for problems. We could analyze performance, flexibility, security, and so on. There are well-established analysis methods to assess quality of systems. I don't talk about that a lot. If we had more time, maybe ask me in the breaks or whatever. Let's look at some data. Often when I support development teams in the search for problems, they look at source code, but they forget data. In our Venom system, we have 5 tables in a relational database, each with more than 400 columns. Let me say that again. A relational table in a database with 400 plus columns. 400 is 4 times the size of columns the Oracle Query Optimizer can optimize. Anybody know about query optimization? It's a graph theoretical problem. It's NP hard. So the more columns you have, the more difficult optimization becomes, and Oracle itself declares the optimizer cannot handle more than 128. And if you have a query in such a data model without optimization, it's like looking up the data by hand. It's the most imperformant data structure I've seen this live. If you don't believe it, I can tell you it was really live. It was a Swiss client. They really had such a data structure. Grown over time. How can you grow such a structure? If you have 300 and you need another kind of data, you have no chance to find the right place, so you make it 301. And if you do that, and longer do that, and again do that, you end up by 400, 500. So, really bad. The row count exceeds database capabilities. By the way, they needed to unload this Oracle database every 6 months and re-import all the data again. So they had 2 days offline every 6 months. That's true. Now, when we look for disasters in software, a lot of disasters happen in processes, in development processes, like, for example, requirements. If your requirements are really bad, you cannot construct good systems. So if you want to cook for your girlfriend a nice dinner, and this is all the input you get, you won't come up with a nice dinner. It will taste horribly. That's what happens. Requirements, conflict between various business areas, and you as a developer are left on your own. So we have some process disasters. Now, during the last minutes, I mentioned a lot of problems. All these orange cards represent problems. And yeah, usually when you analyze existing systems, you find many of those. Now, our Aaron, this technical manager who initiated this search for problems, concludes a bit more specific, a bit more detailed, and says, oh yes, we have problems, but many parts of the system are good enough. So we don't need clean code in all parts of the system. We have very competent developer teams. Remember, our former manager said the developers are stupid. No, they had bad requirements and overly tight schedule. What he proposes, we have to come up with a simplified version of the system. And we have to modify our development process. We have to come up with a real product owner role. We have to put all the pricing stuff into a real single component, and so on and so on. Please note, these cards are green. These are solutions to some of the problems we found before. Now, his overall approach is continuous restructure. That's what I really like teams to do. Instead of trying a big bang, make a more continuous way to improvement. Combine your improvement, here in green, with your daily business. Don't stop the world for a few months to improve something, but combine day-to-day work, day-to-day feature development with improvements. Now, we had some process issues. This Aaron decides to let the process issue be handled by somebody who knows about process issues. And we as software developers, we are not good at organizational change. I have experienced this transition to Agile. Are you working Agile with Scrum or something like that? In development teams, it's quite simple to introduce because developers like it. But in other parts of companies like sales or marketing or HR, whatever, it's very difficult to introduce. And as a software developer, you don't want to try that. So, this lady, I call her Bea, she introduces Agile in IT operations, in sales, in organization, in marketing, and whatever, to better align the business with the development. This Aaron proposes to improve the system by extracting stuff that doesn't belong there. Schematically shown here, we have our bad system. My pointer is gone. There are some features that don't belong to the system, like middleware. You don't need to implement your middleware in your system. So what we should do is we extract some parts of the source code into their own systems. Think microservices or think self-contained systems. That's the way we are aiming at. Now, in the third step, you can optimize the extracted features, and your original system has been reduced. So the amount of source code you have to care about has become a bit smaller. We call this strategy change by extraction. So try to extract part of the system you don't really want in your core. Another approach is splitting your system. Now, we have various client types, these non-profit organizations, embassies, and so on. They have different requirements, and we could split the system into one system for embassies, one system for non-profits, and so on, and optimize all those in themselves. Let's make this for our Venom system. This manager proposes to split out the non-government, non-profit part of the system. So we take our overall system, this huge mass of components, and we can delete a lot of those that are not used in NPOs. And that's the result. It looks way more tidy, way more manageable than the one we had before. We extracted out a few components, and I did that in reality. The system before was more than 2 million lines of source code, and the extracted NPO system has only 200,000 lines of source code. That's a factor of 10, the magnitude. Reducing a system from 2 million to 200,000 lines of source code is a magnitude of improvement. It really makes it way more simple to handle. We now have two systems, one for non-profits and one for the rest. Are you somehow with me? All right. 3 months later, we are finished with our extraction and splitting, and I did a retrospective in one of these teams after 3 months. They told me that instead of 30 days time to market, they reduced to 5. So instead of waiting 6 weeks until you have a change implemented, you have it until next Friday. The production bugs, formerly we had we had more than 10 bugs per week. Now we have 2. Developer happiness skyrocketed. People are now proud again to work for the company for that system. Instead of quitting their jobs, they like their work again. So this is just an example, and now we have proven that this splitting out of subsystems into more self-contained applications on their own really works, and Aaron decides that we will continue this split. Aaron introduces the role of software architecture into development teams. Up to now, we didn't have architects. We had a lot of developers, and some of them were called engineers, some developers, some senior developers, but he decides that architecture should be made a default skill in teams. Aaron decides that we should have a minimum amount of architecture documentation. Who of you is happy with their architecture documentation? That's not too many. There is another open source approach called Arc42, Arc for Architecture. I'm involved in that, but it's an open source project to support architecture documentation. It doesn't make your architecture better, but it probably makes your communication about the architecture a bit more simple. Now, 9 months later, we have re-engineered our pricing. Very critical hotspot in the architecture is now migrated from Haskell to Java. That's a great success. 1.5 years later, business turnover is becoming better. We now have a full mobile application working. It takes a while to migrate from that action script Flash-based. It's nothing you do in a sprint. 18 months later, business really feels, the strategy has worked out. And now the third fake fact, my Aaron technical manager joins Apple to found a bank. Aaron, formerly responsible for the Venom system, disclosed his immediate move to Apple into California. That's obviously not true. I have no idea why Apple doesn't found a bank, because they have 1 billion clients with their payment data, and that would be a good bank. I would join if they asked me to. That's my take on a story of how to move from a disastrous system to a better system. Not all problems are solved, but the core problems, the high priority problems, have been addressed. It takes some time, so please don't expect change to happen in a sprint in 2 or 4 weeks. It will take some time, but it's systematically possible to move from a really huge, disastrous legacy system into way smaller, way more manageable units. Thank you very much for listening, and have a nice conference. Thank you.
Thank you, it was awesome, and especially the story about the minister. В 12 Архан Гасимов на перерыв 5 минут.